We're basically saying we have a population, and we don't know exactly. We can't afford to go and get information about every single person, every single product, every single item, every single entity of that population. So we'll draw a sample. We'll come up with this, looks something like a probability distribution function, an empirical distribution function. We'll use our sample information to therefore say something about the population probability distribution. And that's what this is getting into. We'll also look at that sample and we'll say, okay, let's look at attributes about the sample and then project that and say, you know what, we think that's a good estimate for the full population. So first we're going to look at some sample statistics around the location or central tendency. And you may have heard of these: sample mean, sample mid-range, sample mode, sample median, and sample percentiles. So sample mean, you may have heard of this before. Basically, you're just adding up all the values of your sample results and dividing by the size of your sample, 1 over n. This is a frequently used statistic, sample mean. It's easy to understand. It can be misleading due to extreme values. So I could have a sample that I draw and it's got, maybe it's got, let's see, number of basketballs that you own in your home. And maybe for the majority of us, maybe we own 2. So we have 50 people that say, yeah, I have 2 basketballs in my home. Well, then you get all of a sudden, let's say 5 NBA stars, and they have all the basketballs from all their games or something. They each have 100. So if you were to add those 5, so you got 500, and then you have 50 of us who have 2 balls in our home, let's say. So you've got, 600? And what's happened is those NBA stars have horribly skewed what your sample mean would be because they have just swamped it with their 100 balls each. Kind of an odd example, but it is Maverick season, so that's what's on my mind these days. But so hopefully that gives you an idea. So it could be misleading due to extreme values. And you have to watch that as you collect your data and work with it. Okay, sample mode, the most frequently occurring value in the sample. So again, if I had a sample I drew and it had values, whatever I'm drawing, I have, take a sample that's 5 values in it, 5 observations, and maybe the values turn out to be 2, 2, 3, 4, and 5. Well, my sample mode then would be 2 because it occurred twice and the others only occurred once as a value in the sample. Could have more than one mode. So if I draw a sample of size 5, I could have 2 2s and then 2 3s. And then one person or one observation had a value of 4. So then I would have 2 modes. The first mode would be 2, the second mode would be 3. May not be a central value. I could have 100 observations and maybe I have quite a lot of them clustered around a particular area, but then, maybe there's a bunch that are just on the upper end of values. So it's not really a central, it could be that it's not a central value, the most frequently occurring. Not often used. And I think if you saw this in a magazine article, most people wouldn't know what the sample mode is. Sample median. Basically, you're arranging the values in your sample, the values that you find, your observation values. You arrange them in a numerical order, and then you take the middle one. And this is just giving you a way of saying, how do you find that middle one? So if your sample size is odd, you add 1 to that, to your sample size, and divide by 2 to get the middle one. If your sample size is even, then k is equal to n over 2, and you've basically got, you've got a difference between, do you truly have a middle value, or do you need to take the average of two dead center values? Again, not well understood nor accepted. Does not use all the data. So you, and this is easier for me to explain in class, so I'll come back to some of these points when we're together. But it, you could have all sorts of things. You could have 10 ones lined up, and then a 50, and then you have 10 hundreds on the other side of that 50. You're not really getting too much visibility into what your data looks like or what your sample result is with a median. You're just seeing that middle number. Okay. The other thing we do with a sample, we look at certainly, we look at can this sample be used to predict what the probability distribution might be for the full population? Can we use a sample to and estimate the true population mean or average? And then we look at a bit of like how spread out is our population, and can we use our sample results to give us an indication of that? So here's 3 measures that are looked at. The sample range simply takes the largest value that you get in your sample and subtract off the smallest value that you get in your sample. Easy to figure out, easy to understand, helpful to have, just to get a sense of the spread. Sample variance, again, as opposed to going out and, your population may be so large you're not able to go out and query and get the exact information about every single element in your population. So you draw your subset, your sample, and off of this sample you calculate the sample mean. So you determine your sample or your sample variance. You determine your sample mean. And if you look at this is similar to what we had before with expected values. For each observation in your sample, x sub I, you subtract off the sample mean, you square that, and you add those up, and then divide by n minus 1. That gives you your sample variance. To the right of that gives you a computational way to calculate the sample variance. And then to get the sample standard deviation, you simply take the square root of that, just as we have before. Most frequently used measure of variability, not well understood. I would say the average person reading something about election polls or candidate likelihood or investment articles or whatever, not really understood what a sample standard deviation really indicates. Okay, if you'll look out on the blackboard, you'll see 1 or 2 exercises associated with this, just to kind of work through, make sure you get a feel for what sampling, introduction to sampling, and some of the sample statistics that are commonly used. Okay, I'll end this recording session, and in the next one we'll pick up with sampling distributions.